Hey guys, so today we are learning about the real number system. You've actually seen this before in 7th grade, and so we are going to add to what we know from 7th grade now on to 8th grade. So the real number system is a way that helps us classify numbers. Just like when we think of ourselves, there are several different ways we can classify ourselves. If I talk about myself, for example, I can say I am in the group of females. I am the group of females who work at South Middle School. I am the group of females who work at South Middle School who also live in Edinburgh. And so we can continue going on and on and on, thinking about ways to classify myself. And so we do the same thing with numbers. And so we're going to start, so whatever I present, you're going to write in your journal. So make sure you are ready with your journal and your pencil. We're going to start with natural numbers. So natural numbers are numbers that we can think of when we teach a baby how to count, right? So I have a 2-year-old daughter and she's learning her numbers, and we start with 1. 1, 2, 3, 4, 5, 6, and so on. And so you'll see on here that these 3 dots mean that it continues forever. And those are all considered natural numbers. So on the right side, you'll see a little visual right here, a little cup. So I can put natural numbers, any natural number in there. Let's say I put 10. And I can fill that cup with a number 10. So again, you're going to copy this rectangle, write the word natural numbers and the examples in there, and then the cup on the side. And we're going to be adding to this, so go ahead and start with natural numbers like in the middle of your page. So next we're going to now include 0. So natural numbers are 1, 2, 3, and then now we're including the number 0. So whole numbers, that's what these are called. Whole numbers is 0, 1, 2, 3. So it's 0 and all my natural numbers. So I am not able to say that 0 is a natural number. Remember, natural numbers start with 1, 2, 3, but whole numbers are 0 and the natural numbers. So like on my other example, I had 10. Well, 10 is in this cup. So 10 is not only a natural number, but it is also a whole number. And I can think of whole numbers and numbers that don't have a decimal. Next, my natural numbers and my whole numbers also have a very special name. And the name for that is integers. So you'll see that here is my list of whole numbers. That includes my natural numbers. But integers now also include my negative numbers. And not just any negative, it has to be a negative whole number. So it's not just any negatives. Like if I tell you negative 2.5, well, that is not an integer because it's not, it is a negative, but it's not a negative whole number. See, so I'm going to go ahead and write that there. So it includes negative whole numbers. Okay, not decimals. So you might be thinking, well, then where do decimals go? We work with decimals all the time in class. We saw them yesterday. So where are those decimals? And you guys know that We looked at the vocabulary, repeating and terminating decimals. So where do those go? And then up here, like I said, 10 was a natural number. It's also a whole number, but it's also an integer. All right, so let's continue. So we can also call these numbers rational numbers. So rational numbers is a set of numbers that includes my integers, that includes my whole numbers, that includes my natural numbers. And so rational numbers can be represented as a fraction, and we've already seen this vocabulary word. So rational numbers include my natural numbers, include my whole numbers, include my integers, but also includes my repeating decimals and my terminating decimals. So rational numbers are any numbers that can be turned into fractions. I'm going to give you a couple examples. If I have 0.5, for example. Well, 0.5 is a terminating decimal, and it's rational because that can be turned into 1/2. If I look at the decimal 0.66 repeating, it is a repeating decimal, but it is also rational because that can turn into 2/3. So going back to my cups on this side, we said that 10 was a natural number. We said 10 was a whole number. We said that 10 was an integer. And we said now that 10 is also rational. But when we talked about rational numbers, we said that 0.5 is rational. So if I'm kind of thinking of where my numbers start in these cups, and I were to put a 0.5 in here, it would not be an integer, it is not a whole number, and it is not a natural number. It's just in my rationals cup. And 10, well, 10 started here. So this cup is now in this cup, which is in this cup, which is in this cup, all the way down. So we've been working with irrational numbers, right? When we were talking about square roots that are not perfect squares. So irrational numbers are all the numbers that cannot be represented as a fraction. Just like the square root of 32. Square root of 32 is not a perfect square, so the square root of 32 is irrational. Pi is also irrational. Even though we use 3.14 when we are in 8th grade, that is just an estimate. Pi is a special number that continues forever. So pi is actually 3.14159265897, and it continues forever. So there's no way I can turn that into a fraction. All right, so if I go back to thinking about the 10 was a natural number, a whole number, an integer, a rational, which means that it's already in this side of my cups. There's no way it can be irrational. Just the same as pi. If I put pi in this cup, there's no way that pi can be anything else. It cannot be natural, it cannot be whole, it cannot be an integer, and it cannot be rational. And this whole system, all of these numbers, are part of the real number system. So every single number is real. Now you might be thinking, so why is it called real number? If all of the numbers are real, what's special about that? Well, when you get to college, you'll actually learn about imaginary numbers, which we won't get into now, but it doesn't stop here, and that's just for later upper algebra and math classes. So what I'm going to do here is I'm going to model the thinking that you should make when you're trying to classify numbers. So I'm going to think out loud to classify the numbers that I have down here. I like orange. I don't want to yellow. All right, so looking at my numbers, I see pi, and I just explained pi on the last slide, so I know that pi is irrational. All right, next, looking at my numbers, I'm going to look at 0. And I know that Miss Oli said that 0 is not a natural number. We don't start teaching babies 0, 1, 2, 3. We want them to count on their fingers, right? So 0 is a whole number. Now notice where 0 is in my cup. If 0 is a whole number, put W for whole number, that means that it's also an integer. And if it's an integer, that means that it's also rational. And if it is rational, that means that it is also real. So 0 is a whole number, an integer, a rational, and a real. And I really like the cups because it really shows you what part of that group it is. If we look at the squares over here, we see that it's a whole number. And whole numbers are inside the box of integers, so it is also an integer, which also makes it rational, which then in turn makes it real. All right, so let's try another one. Let's try -7. So -7 is not something I teach a baby. -7 is not on my counting fingers and going forward. So -7 is not natural. Negative 7 is also not whole because it's whole, but it's a special kind of whole number, which is a negative whole number. It's not a whole number. Whole numbers start with 0, 1, 2, and it's all the positives, only the positives. So that means that negative 7 is an integer. It is a negative whole number, and it does not have a decimal. So if I was going to classify negative 7, I would put negative 7 here in this cup. So negative 7 is an integer, which makes it rational, which makes it real. And I'm going to do this so we can have more space. All right, the square root of 36. So I remember from class that the square root of 36, that 36 is actually a perfect square because 6 times 6 is 36. So if the square root of 36 is equal to 6, it is actually a natural number. Why? Because my little cousin or a baby will start with 1, 2, 3, 4, 5, 6. So 6 starts as a natural number. That is the very most basic category. And if it's natural, it's whole. And if it's whole, it fits in my integers cup. And if it's an integer, it fits in my rational cup. And if it's irrational, it's in my real. And again, all numbers are real. I'm going to erase this so we have a little more room. All right, next let's look at the square root of 3. Again, the square root of 3, I have to think of my perfect squares. 3 is not a perfect square, which makes this irrational. And also real.
Any available custodians, please report to the gym. Any available custodians, please report to the gym.
All right. Next, 0.25. So that is not a natural number. It's not a whole number. It's not an integer, but it is a rational number because it is a terminating decimal. So if it is rational, it goes in this cup. It is rational and real. All right, so I'm going to show you the next one, negative 11 over 13. So a lot of students see that negative and they automatically want to say, well, it's an integer because it's negative. So that's not correct, right? Remember, we know that integers are only negative whole numbers. So I know that it's not an integer, and I see that it's a fraction, and I know that rational numbers are fractions. So negative 11 over 13 is rational and real. All right, next I'm going to look at this one right here. I see these 3 dots right here, and that tells me that it continues forever. So I'm thinking, well, is it rational? Because I know rational has some numbers that continue forever. But does it have a pattern? So I have 0.1269278. I'm not really finding that pattern. So this is actually an irrational number. So this is irrational and real. Next, negative 9.1732. So this one does not have those 3 dots. So we know that this terminates. And it's a negative, but it's not a negative whole number. So it's not an integer. It is a rational number. Again, it is not a negative whole number, so it's not an integer. It doesn't continue forever without a pattern, so it's not an irrational number. It is a terminating decimal, which means it is rational and real. Two and 1/3. So it is not a natural number. It is not a whole number. It is not an integer, but it does include a fraction and can also be written as 7/3. So this is also a rational number. 2 and 1/3. So it is rational and real. 5/12. So 5/12 is not a natural number, it is not a whole number, it is not an integer, but it is a fraction, so it is also rational and real. And the last one, 1.237. So we see this little line on top, which is called bar notation. So that means that it's going to continue on forever. So I'm thinking, could it be irrational? But I know that that little bar tells me that there's a pattern. That is 1.237373737. So because it does include a pattern, it is rational. So if that goes into my rational cup, it not only will fall as rational, but it will also be in my real cup. So that is the lesson for today. I know that it's a lot of vocabulary. I know that we take a little bit of time to learn this, but that's what we're here to do. We're here to practice and we're here to learn. Like I said, I know that in 7th grade they teach you rational numbers, integers, whole numbers, and natural numbers. However, in 8th grade, we are responsible for learning about irrational numbers, which all together makes the real number system. I hope you guys had a great time learning. I will see you again another time.